Hello and welcome back to E-Time's, we're on the big one, focus. Hello and welcome back to E-Time's live streaming coverage of Embedded Systems Conference 2011 from the show floor of the San Jose Convention Center. I'm Brian Fuller, Editorial Director of EE Life. And our next segment this morning is a gentleman from Ramtron, Alex Tsui.
Yep.
Did I pronounce that correctly?
That's correct.
Alex Tsui. He's Worldwide Marketing Director. And he's going to talk about FRAM technology and a new product that Ramtron has out. And as many of you may know, FRAM has been kind of a very, very promising memory technology for a long time. For decades, it was kind of the thing that was going to just come down the pike. And it never sort of took off. But in the last 5 years to 10 years, it's really gained some traction as a technology. So Alex, tell us a little bit about what you guys are up to.
Okay. First of all, I want to give you an introduction about FRAM technology. Basically, it's a non-volatile RAM. It marries the best of the both worlds of volatile memory, like DRAM, SRAM. Those memory has advantages like unlimited endurance. You can write as many times as you want, and it's write very fast. And for SRAM, the power is very low. But this kind of memory is volatile, so it needs battery to back up the data. The other camp is non-volatile memory. So like eScript on a flash, you don't need a memory you don't need a power to retain the data.
Right.
So, but this kind of memory has a limitation like the number of times you can write, the write speed is very slow, and you need high power to write it. So FRAM marries the best of both camps. It's non-volatile, ultra fast, virtually unlimited endurance, and ultra low power memory. So
this week you're coming out, or at least at the show, you're talking about a product that has integrated some interesting features. Talk about it.
Right, yeah. So nowadays FRAM is mainly used in data collection applications. So because you need to record the data and you want to keep the data when the power is gone. And it's widely used in all kinds of applications, automotive, metering, industrial, computing, military, all walks of applications. So this product we generate at this show, we launch at this show is our third generation so-called processor companion family. So along with FRAM memory, we integrated into this family real-time clock and system management functions so that we also help the host processor to monitor the system conditions. If there are anomalies happen, it will make sure the host processor take the necessary actions to ensure data integrity. And also there's a common peripherals that offload some of the works from the processor. So we call it processor companion family. It's integrated most of the common needed functions for processor-based systems. So this third generation, we further embedded the crystal for real-time clock and a temperature sensor inside the product so that the temperature sensor can sense the temperature and do digital calibration to compensate for the frequency drifts of the crystal characteristics over the whole temperature range.
Okay, so this is the third generation of that product, first time you've integrated that in that way.
Yeah, exactly, Brian. So the previous generation, we have the real-time circuitry, but the customer needs to use an external crystal as the base clock timing signal. So and there's no temperature compensation, obviously, because the crystal is external. So the temperature variations, the frequency variation, depending on the characteristics of the crystal, can vary maybe between 30 minutes to 1 hour over a year period of time. So now with the crystal embedded into the circuit and also with a temperature sensor to do the calibration and compensation, we reduce that error to plus or minus 5 ppm per year. That means it's less than 2.5 minutes over the whole year time.
So so there's obviously a design. There's a trade-off for the customer there. The customer gets more functionality because you've integrated this thing. But is the die slightly bigger, and presumably it's a little bit more expensive?
Not really, Brian. With the putting this together and also other functions, we have all these. We can call 4-in-1: the FRAM technology, memory technology, the real-time clock, the common peripheral functions and the system managed functions. We managed to put everything inside a 14-pin standard JEDEC low-profile SOIC package, which is actually the smallest form factor if you compare to any other TCXO, with temperature compensated crystal standalone solutions in the market. So it's a thinner, smaller, and actually cheaper.
So to put the cart before the horse, what's Rev 4 look like? I mean, where are you going to take this thing going forward?
We probably, as you can see, there's a trend of Ramtron. We started from the underlying ferroelectric RAM memory, and then we're moving towards more system on chip, SoC kind of a concept. So the processor companion is kind of a low or medium complexity SoC solution. We are going to put more complexity and intelligence into the future solutions.
Cool. Well, Alex, Tsui, thanks for stopping by and telling us about your product. Have a great show.
Yep. Thanks very much, Brian.
No problem. So that was segment 2. We're going to now take a very brief break and bring in our next guest, sort of unscheduled because it's not on the schedule. But if you saw our first segment, it was with the kids from Sparta High School in Sparta, Wisconsin, who won one of our E-Times ACE Awards last night. We're going to bring in a graduate student from the University of Arizona who won our Student of the Year Award, and we're going to chat with him in about 2 minutes. So stay tuned. Hang in there.